today the information live. For folks who are going to be in need of the information at a later date, we will have all of it available for you for future reference. I'd like to welcome you to today's FACE Conformance Program Overview webinar. My name is Judy Sorrenzia. I'm from the Open Group, and I am the Program Director for the Future Airborne Capability Environment FACE Consortium. We have two additional presenters today. We have Marcel Padilla, who presents NavAir, who will be giving us technical overview, executive overview about the FACE technical standard and some details about what sections and segments of the standard that you would need to conform to. And we have Steve Getz, who represents US Army AMRDAC, information about the policies, documents, process that you go through for FACE conformance, and how to get more information not only about the process and the steps, but how to contact our various verification, certification, and library administrator authorities who comprise the FACE conformance program as well. So we will get started. Simon, if you could go to the next slide, please. For those of you who are not familiar with the Future Airborne Capability Environment, we are an industry collaborative organization. We operate under the umbrella of the Open Group, which is a global consortium who focuses on business objectives through the use of open standards. FACE Consortium, the FACE approach is a government industry software standard and business strategy we are using to enable folks to acquire affordable software systems, rapidly integrate portable capabilities across global defense programs, and attract innovation and deploy it quickly and affordably. We want to change the current business model from develop once, charge 10 times, pay multiple times for capability with proprietary wrappers on multiple aircraft to the point where we have reusable, portable, interoperable software that men and customers can use to procure differently, and software suppliers can expand into a horizontal market and be more innovative in how to size their software across multiple product lines to support the warfighter and give more capability to the warfighter faster. I did mention that we're developed through an industry and government collaboration through the Open Group, FACE Consortium. We have 90-plus member organizations participating and over 1,100 individual participants on roster. We've grown exponentially over the past 6 years, and very proud of the fact that we are now in a position to put the business strategy in place in order to enable the standard and the adoption and uptake of the standard to propagate to the customer, which is right now government and software industry. Next slide. Benefits to government by developing an open standard using a collaborative environment between government and industry to meet the better buying power needs that are called out as a lot of the directives from the U.S. government. Buying power enables us to increase competition, achieve affordability, and control the overall life cycle costs of the multiple programs for the various aircraft that are out there for Army, Navy, Air Force, some international communities as well. We want to incentivize productivity and innovation in industry and government, and ultimately reduce software development times, saving time and money through modularity and portability. It allows for cross-program or cross-platform decision-making. Reuse is one of the primary tenets of the FACE approach. Use applications across multiple platforms without any cross-platform dependencies. Divest multiple times for the same capability. Enable integration of cross-program requirements. Industry benefits as well. The FACE approach enables industry to create software-centric line market opportunities, so they can develop capability once and use it for multiple customers across multiple platforms. It also provides the opportunity for software capability across multiple aircraft types, which may not have been available to them before when they were just supplying product for one customer. This enables them to get into a market where multiple customers can benefit from the capability that they have. It also lowers their cost of doing business. Common standards cost and schedule risks. If it's developed once, the QA quality is done once, and it'll work once. It's proven to work in multiple environments. Standardization also allows for rapid development of capabilities. And software enables integrated to optimize platform performance. So they've tested it once, they've integrated it once, the learning curve goes and folks can do things quickly, again with the ultimate goal of getting high quality capability to the warfighter faster and in a cost-effective way. Next slide. So I talked a little bit about where you can find more information about the FACE approach. We have a landing page, www.opengroup.org/FACE, public-facing site. We also have a website that we use for collaboration among our members. If you're interested in joining the FACE consortium, finding out more how to participate, we can give you a little bit more information about that at the end of the webinar. But the landing page will give you information about consortium activities, information about the public documents and tools that we use to support developing FACE software, and some of the things that are out there available. The FACE technical standard, we've got edition 1.0, 1.1, 2.0, 2.1, and its related documents that are associated with that. We have a reference implementation guide for each edition of the technical standard. We also have a conformance verification matrix that's associated with each edition of the standard, and a model that's available to correspond to editions 2.0 and 2.1 of the FACE technical standard. In addition to that, we have some of the conformance policy documents, performance guidance documents, information about library requirements, and information about business guidance, as well as the FACE contract guide, which will enable customers to find information about how to procure FACE conformance software, and suppliers to find information about how to put contract language together to offer FACE conformance software in response to an RFI or an RFP. All of this has been put into place only to document the technical standard and guidance for how to develop software so that it requirements that are defined in the technical standard, but also the business strategy and tools techniques so that government can procure and industry can provide FACE conformance software in a mechanism and in the language that meets contract requirements. Our big announcement is that we are live and ready for business. The FACE conformance program has all of the pieces and parts in place. We have documentation in place. We have our conformance authorities in place, the verification authorities who will run through for the record testing of the conformance test suite and some of the other tools that we have for developing and testing that the software does meet FACE conformance requirements. We have the FACE certification authority in place who can confirm that testing was done correctly and can ensure that all of the legal agreements are signed and ensure that a certificate is issued to prove that software is conformant to the standard. And then we have the library administrator in place who can confirm that software has gone through verification, that it has been certified as conformant, is listed in the registry. And the only way that we 100% guarantee that software is certified FACE conformant is if it completes all three steps. So listing it in the registry is the last step of the game, and we're very, very happy that we have all three of the authorities in place. And our panelists that are coming up later will give you more detail about the technical aspect and about some of the processes that are in place and procedures that are in place in order to enable making that happen. So you may be wondering, and I will go into a little bit of detail here about why it matters. You can technical standard. You can have organizations that work very hard on developing a technical standard, and you have zero customers that are interested in using any of the capability that's built based on the technical standard. What we'd like to see happening here, we want to make sure that we have vendors who are invested in doing it right. There are customers who are very interested in seeing phase conformance software. There are customers who are very interested in seeing that commonality, reusability, interoperability on most of their aircraft. And we want to make sure that the software that is produced to conform to the phase technical standard does indeed conform, and it is interoperable, and it is portable, and it is reusable. So by certifying that vendors have gone through the process, completed all of the steps, it identifies who has been doing it right. It's a delineator between who is making claims that they're phase conformant, who is making claims that they're certified, and who has actually done the job. And having the product listed in the phase registry, it gives you a way to check. You're either conformant or you're not. It also lets customers buy with confidence. Conformance has been proven by a third party, and they do not have to go out and spend or invest additional money or do any additional investigation. It's been verified, and the vendor is going to warrant that it's going to stay conformant until of the product. And if it's found to be not conformant, they are warranting that they're going to fix it so that they make it right, so that it can be reusable and interoperable. And we realize the value when customers make their choices based on certified conformance. We want to see products populated in the phase library. We want to see choices available for customers to pick and choose among phase conformance software, so that they have a place to go to get reusable software. They have a place to go where they have confidence that what they buy is going to meet the needs, because the requirements have been vetted, the requirements have been included in procurements, and the customers have supplied products that do meet those needs. It gives vendors a place to provide a marketplace of conformant products, so that they get the word out that my product is out there, I is conformant, I match the APIs, I've done all my testing. You can choose my product and have confidence that the integration cost will be reduced, time to field will be reduced, and ultimately, again, it's back to getting capability to our warfighters faster. So I'm going to introduce our next speaker. We have Marcel Padilla from Navarre, who is going to give a little background on why we started not only with the technical standard for avionics on military aircraft, but also some background about the business strategy that is going to enable us to standard and get capability to the warfighter by generating phase conformant products. So with that, I will turn things over to Marcel.
I'll go to the next slide, Simon. Try. So when we started this project, we realized that back in the early 60s and 70s that we were building avionics systems and aircraft, and they were very purpose-built. It allowed us to give the industry developers freedom to develop whatever needed to happen in a very expeditious way. At the time, there was no constraints on finances or money. That resulted in proprietary solutions at multiple layers within an architecture, described in the left display on this slide. Along the 80s comes the iPhone, which is an innovative approach. And while some people will say the iPhone is a closed system, it actually has opened up quite an open architecture on the application side by rigorously defining an application interface and then providing tools for people to develop applications independently that can be loaded, and integrated onto that device. However, the way to manage that, the company has some middleware and operating system and hardware to make sure that the supporting infrastructure was assistant. And then because of that, that was creating such a competition market that some of the phone providers were losing ability to compete. So coupled with Google, they formed a consortium to develop the Android operating system, which is a custom middleware and operating system combined. And also allowed to open up the application space, finding an application interface and tools to develop to that, but also opened up what we call the box side to the hardware to allow the phone and small device providers to create hardware and compete in that market. So while iPhone still has a large portion of the market share as far as revenue, Android has taken over a lot of the market share for the actual devices. We started the FACE Consortium because of the government's rules for open competition in all cases. We want to make sure that we had open competition in every portion of the system, which included applications, middleware, operating system, and hardware. Now, FACE itself, the standard does not address hardware. The intent here is that we address the ability to abstract software from hardware to allow any hardware to compete in that market, but we are not defining hardware interface. So approach, I mentioned a little bit on the previous slide. Each platform, avionics platform, had to develop the unique software and the mission sets and boxes and integrate them independently. So what ended up with, as you see on the left side of the screen, 4 aircraft might need the same equipment, but it had to be integrated 3 different times, and each one of those would have a different software load because only portions of those systems were required for each of the aircraft based on their mission set. This caused a lot of integration cost, and as you see, multiple integration efforts. With the FACE approach, we would like to be able to develop those capabilities such as survivability and sensors and terrain awareness one time and utilize the FACE software architecture to minimize the integration that would have to happen one time for each platform, taking that capability and reusing it and only changing the software that was needed to integrate it. This allow cross-platform decision-making because we can have common capabilities across platforms and thus lower acquisition costs for not having to purchase the same capability multiple times. The FACE Consortium, we established these objectives, and they've been persistent throughout the 6 years of our life. We want to establish a common operating environment to support portable capability-based applications across the Department of Defense avionics system. Since then, we realized that our software architecture approach is not constrained to the avionics system. It's just good software business practices. The goals that we set upon ourselves was we needed to determine a strict set of open standards to establish this environment based on the principles of open architecture, integrated modular avionics, and MOSA, the Modular Open Systems Approach. And attributes of our architectural approach should include portability, modularity, partitioned, scalable, extendable, and secure. To do this, there was a demand from the customer to reduce lifecycle costs and time to field. How are we going to do this? We had to obtain industry and DoD program management endorsement, which is why we entered into a consortium, government industry consortium. And lastly, we were going to finally come with the hammer that many standards do not bring, which is we need performance to ensure that the requirements have been met to maximize the interoperability and portability that the standard was defining. I'll go to the technical overview now. The tech strategy was quite similar, or quite simple, I'm sorry. On the left side of the screen, we have portable applications that wanted to get from one environment on hardware to new hardware. We did not want to address avionics networking. There are many other standards bodies that are working those aspect. We wanted to focus on the actual software that does the capabilities or functions that we needed it to do. And I'll get more detail as we go through. So architecture, as I mentioned, it's a computing environment that will enable product lines for military aviation or any other software product line development. We've established a set of places or segments where we have points of variance. Inside those segments, there is design flexibility as long as you meet the boundaries, the requirements of those segments, and the boundaries of those segments are bounded by robustly defined interfaces. Vertical interfaces that are defined in the standard, such as operating system interface, the input-output interface, and the transport services interface. The system interface is based off of two readily available standards, the POSIX standard, as well as the ARINC 653 standard. The interface is a very simple, normalized interface that I'll talk about in a following slide, as is the transport services interface. The horizontal interface is standardizing the way data moves throughout this system. Originally, we bounded this system is within the skin of an aircraft, but be within the partitions of one operating system, or between or inside one box, or between multiple boxes. But I said we're not trying to standardize the communication pathway between aircraft, networking, or those types of things. And what's on the software architecture itself. So what are the barriers that we were trying to solve? Portability is what we wanted to do. Reusability is the goal. The first step is making sure the software is portable. So on the left side of the screen, traditionally, we would expect software developers to get a list of their givens, included what display am I outputting my data to, what hardware am I running on, what operating system am I running on, what bus am I transmitting data on, any other software components that I'm tightly coupled to. And all these things would govern I wrote my software, and typically I would embed all of those specific functions into my software. That is, anytime one of those things would change, then I would have to rewrite a portion or all of my software and have to potentially retest all of it. So we categorize those concerns as presentation concerns, input-output concerns, and operating system and driver concerns. The dependency on other software we can manage as well. So to deal with those challenges, what we did in the FACE architecture is basically identify those concerns and mitigate them with creating adaptation layers to deal with those, so that we isolate the green square on the screen, which, if you can see, is business logic or the algorithm that we really want to reuse and leverage the investment on that critical capability. More detail about what those adaptations are, but what these allow is that when the display changes, I just change the adaptation software to the display, not the business logic. If my bus that I'm running data on changes, then I change the adaptation layer to that bus. If the operating system changes, it does because I am standardizing on a strict set of operating system interfaces that all of the operating systems that are participating in the consortium provide. And then any dependency on any other software would be standardized by the use of our horizontal interface to make sure that the information is being exchanged in a standard way. So this is a picture of the based architectural segments, plus a couple of extras. I'll use the annotation function on this to help me. I'll start on the bottom. So at the bottom, this is outside of the FACE architecture. The FACE architecture is bounded by the dashed lines, the heavy dashed lines in the screen. And it's hardware. Hardware has multiple meanings. In the case that we're talking about platform devices, effectors, radars, radios, input-output devices, types of things. Step is interface hardware. When we talk about interface hardware, the examples are listed in there: MIL standard 1553 bus, Ethernet, Airborne 29, discrete, way that we're going to transmit data across hardware boundaries. Both of the things are in non-standard ways and typically output data in non-standard ways, whether the data from the sensors or effectors are proprietary in nature, or the implementation of the standard interface hardware is implemented not exactly the same. We recognize this from the experience of the multiple companies in the consortium. We realized we had to figure out a way to deal with this change and isolate the change from our algorithms or this logic that I talked about on the previous slide. First step is obviously the operating system, which is indicated by the L shape, the gray L shape on this. The operating system provides many features that any software system would require, which is things such as file systems, network stack, as well as access to the device drivers that are on the actual hardware on the processor. So what we see is that we define an operating system interface in the green line, that the left side of the diagram, and this is going to provide those execution services for all software in every segment. And so the operating system can be used for communication. I'll talk about that in a moment. The next step, though, is the input-output service segment. The input-output service segment is to normalize the implementation of the interface hardware that I discussed here. The point here is that if I have one manufacturer of a standard 1553 card, another manufacturer, they may slightly implement the standards slightly differently, and because of that, the outputs will not be quite the same. So the purpose of the I/O service is to take that proprietary implementation and normalize that so the data is passed through the output interface in a normalized fashion. Those are very standard and very simple here. Input, open, read, write, send, receive, and then there's a standard message format that the data is put into that is defined in the standard. Part of the I/O service is that it does not understand the data. Its only purpose is to take the data from the interface hardware, put it into standard envelope, and pass it through a normalized interface. What it allows is that if I change from one vendor 1553 card to another, I only have to replace this component and I have to replace any of the other software in the system. So move stack, the next segment that the face architecture defines is the platform-specific services segment. As in its title, this still has some specificity, is not completely isolated from the outside world. I'll talk about a few sub-segments. The first one is the platform device services segment. The primary role of this device, or this is to take a sensor and that ICD and transform the data into a standard format that's defined by the face standard. This allows this service to take this information it receives from the I/O service that's received from the bus that received it from the sensor and cut that into data that the rest of the software in the system can understand in a standardized fashion. This all allows for ability to control some basic controls of that sensor or effector. But what it also allows is if I have a sensor such as a GPS device and I went from one vendor to another, I can replace that GPS device. I only change this piece of software, the input service, or the software that would consume the data from that. The intent of the face architecture is to isolate change away from our valuable algorithms or business logic at the top of the stack. The segment in the platform-specific services is platform common services, which includes things such as health monitoring, fault management, configuration services. FACE does not define requirements for these. It defines the requirements on where to put these in the architecture, so don't inadvertently tie your business logic to health monitoring, fault management, or system-level configuration. You can isolate that by creating a separate component if you change your requirements of your monitoring or your configuration. It does affect your portal application. Third subsegment in the platform-specific services is graphic services. Realize that many graphic services are closely tied to their drivers, such as OpenGL, and we didn't want to add additional layers of interfaces or processing, as sometimes there's some latency challenges with graphics. So we identified a way to deal with that and identify the graphics interfaces that they're allowed to use, and in some cases go direct to the driver. Once the data come through any of the components here that needs to go to be consumed by my business logic, it will go through the transport services interface. Transport services interface is, again, another normalized interface, very simple: open, close, read, write, send, receive, and callback. Basic functions are the syntactic interface, but we introduced the face data or type-specific interface that actually sends model data that understands the semantics. We have a semantic interface of the data. So point forward, all the software not only has a standardized interface syntactically, but also semantic understanding of the data. Services has some mandatory requirements in these to provide the services. It needs to provide routing and configuration at a minimum. It also has some condition requirements that are available, and we provide requirements on how to implement them in a standard way, but you are not required to implement them in all cases. Things like data conversion, data marshaling, quality of service, and those are all system-level requirements depending on your integration. What the FACE standard has done is defined to put that information in your architecture so that you do not inadvertently put that information in your valuable business logic, so you have to change your business logic if you port it to other systems. The transport services is the transport services interface. So just the way we've drawn this diagram as a layered, it's going to depict it this way. I have a slide on the next slide that will depict it a different way, show it only as one interface. But that goes to our portable component, and our portable component, of course, will take this information. It only has an interface it only has to speak to the transport interface, and it only has to speak to use the OS interface. And other than that, this is where it provides industry that the valuable innovation that they create, all of their excellent innovation and capabilities in these capabilities. Because they're standardized in layers, there are industry middleware makers that can compete in the transport services layer, and there are sensor and effector developers that can provide their platform-specific services that accompany their devices that they sell, and are interface bus hardware developers that can provide input-output service with the components to further allow their capabilities to be integrated using FACE architecture. The picture of the FACE architecture, it is exactly the same architecture, just drawn differently. This one has a few examples, and I'll very quickly summarize my previous conversation with a bit of a data flow. So using a GPS as an example, want to get GPS data displayed onto my display. I start with a GPS device. It outputs its proprietary data onto the mill standard 1553 bus. It has been integrated on a 1553 card that's been produced by Company A. That driver that the operating system interfaces with, we will run IO service that takes the proprietary implementation of 1553, normalize that data into a standardized envelope, and pass it through a normalized interface to a platform device service up in the platform-specific services. This is data is interpreted using the GS's ICD and transformed into the standard face data architecture and passed through the transport services interface to support service. Service through configuration knows that that data needs to go to application 1. Application 1 will consume it. It will do the calculations and output data through the transport services back to transport services interface back to transport services, out it to specific services graphics to be displayed on a GPU driver and out to the actual display itself. So in case every time any one of those things changes in the loop, we have the ability to just isolate the change at each of the segments. Making our portable applications portable. As we go down the stack, there's a little bit less portability, but if you are tied to the same hardware in all cases, then your software should be portable with that same hardware. Slide that just summarizes kind of the bounding of each of the what we're calling units of portability. You'll also see in the face standards units of conformance, which is what Steve's going to talk about, but basically a unit of portability is equivalent to a unit of conformance. Just a little bit easier for folks to say of how I'm going to make it portable. But in the PCS, the portable component segment, it has to conform to the transport service interface, the operating system segment interfaces, which include operating system interface or programming language runtime or a framework interface. Transport service components, they have to conform to the operating system segment interfaces. And the interesting part about transport services, it provides the transport service interface. So that's the other interface it still has to conform to by ensuring that it provides the transport services interface to its consumers. For the platform-specific services segment components, they need to conform to not only the transport service interface, but also the input-output service interface. That's the reason that we put monitoring, system-level health monitoring, and system-level configuration services in that segment so that they would have access to all interfaces within the software system, as they need to comply with the operating system segment interface. All right. I'm about face data architecture. It's a very robust effort that we've added. So there's a strong meta model in the face standard, and it's robustly documented. Essentially, what we are doing is we are creating a platform-independent model, standardized with rigorous mathematical models to make sure it's verifiable. And what we do is capture the semantic understanding of the data. ICDs have done a great job in the past, but they are only as good as the people who are available to interpret them. By capturing the information robustly into a semantic data model, utilizing these OMG modern architecture principles, we can utilize all of this to create auto transformations if we have independent development of messaging. So I'll quickly go through this, but the conceptual data model is basically conceptual views of information that platform specific at all, air, sky, vehicle, those two things. We'll use data refinement and step to the logical data model view. We start talking about observables and measurements. that we apply and give more context to those console views. This can project a message, and then move to the platform-specific model. We can add in specific information related to aircraft itself or system itself, and then actually create the message. Document the entire tree and message in a unit of portability supplied model delivered with our software. That model can be generate the actual code for the interfaces in using IDL, and we have IDL to language binding mappings can then be used in our integration with our software. So a unit of portability, unit of conformance, piece component segment, and the platform-specific services segment will have one of these delivered with it to provide semantic understanding of the data that it requires. And speaking about conformance, that's the data that to send. Transport Services API provides the structure in which to send it. So every green and blue are required. Sorry, this purple is also kind of hard to see. Those are required, and red and orange are optional. Optional requirements don't sound like they're standard, but the reason they're optional is because these are system-level decisions, and face conformance is done at the component level. So on my system, I'm going to develop a component, and if my system requires quality of service requirements, then I'm going to put those quality of service requirements in the transport services component that I'm developing, and I will add the associated associations that are required. We are providing not only the data model, but structure in which it's sent over the Transport Services API. All this is testable. I will talk about a little bit about conformance testing. Data model. We have a conformance test suite that tests for the data model by verifying that it is constructed to the face meta model that's defined in the standard. It's in standard XMI format. It also verifies that it is paired against the face shared data model, which is a configured and managed list of basis elements at the conceptual and logical level. This conformance test suite will also generate the data types from that U applied model, verify that the data types that are provided in there are the data types that are used by the unit performance that's under test. So very rigorous tests that the test suite does on the data, as well as the conformance test suite will also test that unit of conformance for the interfaces that I mentioned, either the transport interface, input-out interface, or operating system interface. So, FACE is getting capabilities to the warfighter faster at a lower cost by increasing portability and thus reusability. Documentation is being designed through an industry-government collaboration, which ensures that both are reaping the benefits that you talked about at the onset of this brief, and technical standard is being considered for all defense avionics software procurements where reuse is a goal, and commercial industry is also looking at it and has already started to address it. The FACE initiative is addressing business concerns that have hampered other OA initiatives, such as a conformance program. Without a strict conformance program, you can't ensure implementation across the board, and we're very excited about having our program being stood up.
So before you move on and we introduce Steve Getz to get into the details about the conformance program and the process that software suppliers would go through, I do have a question from the Q&A chat.
Sure.
So are conformance tools open source, and are there plugins for standard tools such as Eclipse IE?
Conformance tools are open source. They can be downloaded from the Open Group website, and there's one for each version of the standard. There's actually multiple versions, each version of the standard, and it's not intended to cause confusion. But the consortium identified that there would be contractual limitations, and that we didn't want a vendor to be unfairly constrained by they went on contract and version 1 of the tool was available, and by the end of their contract, version 5 is available. We didn't want to force them to have to go to version 5 unless they had to negotiate that with their customer. So all versions of the tool are available to them. It's expected to use the most current version if possible, but those are all available. They're not tied to a specific IDE. They are done in a generic modeling environment, and they have the ability to be run on Linux and Windows.
Was the only one that came through, so I appreciate that very much. And with that, we will now switch gears and introduce Mr. Steve Getz from U.S. Army MRDAC to give us more information about the actual conformance processes, where to get information about the conformance process, conformance documentation, and going through the various steps of verification, certification, and registration to get FACE software completely certified and listed in the registry. With that, I'll turn things over to Steve Getz.
Thanks. I hope everyone hear me okay. Am I in slides? I am. Okay. So that's me, Steve Getz. And that we have 75 attendees, so I wasn't nervous until just now. Anyway, my intent is, first of all, to provide an overview of the FACE Conformance program, and we'll step through that in some detail. A huge deep dive because we just don't have the time. But I will describe, the policies and procedures and some recommendations that are made in through the FACE Conformance program and getting ultimately certified and listed on the registry. The key takeaway I'd like to stress right here at the beginning is that I'm going to highlight some references and available sources. Some of them have already been mentioned. I'm going to mention them again because I think they're that important and because they're already in slides. So, without further ado, we'll jump right in. Here's a very high-level view of the conformance program and its associated 3 processes, being verification, certification, and registration. And we'll talk more about the content of that slide, but this diagram has been affectionately referred to as the perfect diagram. And so I was involved in its construction. I have no argument. But slide is called the more perfect diagram. And you'll note on the top left, we added a step of preparation. And while it's not an official part of the FACE Conformance program, it is in fact so critical, and that's what we're going to spend a little bit of time talking about as we get through the rest of this presentation. If we don't get down to your question, then at the end we'll have some time where certainly we'll do our best to get you an answer, and if we don't have it, I'm sure we can follow up with it later. We're on this diagram. What I wanted to do was just talk about below from the top left of the software supplier. And let me just describe a software supplier is someone who supplies software, and that sounds a little silly, but what it means is it might be the system integrator, it might be the system integrator. It is not necessarily the person who was the software developer, but who actually supplies the software that's assessed for FACE conformance. So they're the role of the software supplier, and they remain in control of stepping through this process, and I'll talk a little bit about that as we move along. So once you get through preparation, you would initiate verification, and that's done through authority called a FACE verification authority. Have multiple EAs as they're addressed. 2 are from government, 1 Army, 1 Navy, Navy and 2 from industry from Certon and Tucson Embedded Systems currently, and we are expecting more. They are assessed by a EA approval committee to make that they meet muster, and they assert that they will remain current, qualified, and they are in fact an expert on the FACE technical standards and the associated verification methods, by which R2 and Opus touched on slightly. We use test and we inspection or a combination of those two. But they do the testing and inspection of the submitted software as a unit of conformance and its associated verification evidence. If the software supply, once they pass, if the software supplier chooses to do so, they can proceed certification. We have one and only one certification authority, and the certification authority documentation received from the VA and from the software supplier makes it meets the requirement of that paperwork, and then the configure associated with that unit of conformance. There, the software supplier again has a choice to register on the FACE registry, and that's done by addressing the library administrator, of which there's one. The library administrator will look at the descriptions that are offered for the UOC, check with the certification authority to make sure that a certificate has been issued for the UOC that wants to be listed, and then it can be pushed up on the registry. And the registry is a very important part of this process and program. Is the of only FACE-certified UOCs. So if they haven't put conformance and it's binary, you either pass completely or you do not. You will be unable to be listed on the registry, and you also must go through certification. So, slide, and Judy showed, I think, the same slide, but again, I wanted to mention it because it's so important, is the FACE landing page. Focus primarily on what's available related to conformance, but if you are not familiar with the FACE consortium and its architecture and its approach, there's a lot of other information available through this landing page. So this website here, if you haven't put it in your favorites or your bookmarks, I would recommend it if you want to proceed with the approach. So that here is drilling down to the conformance tab of the FACE landing page, and this is where you get the pleasure of doing the more diagram. But there are 4 tabs there, starting on the left, where you can get conformance publications, ranging from the conformance policy. We have a conformance certification guide. You can download the related conformance verification matrices. You can download the test tools, and all these things are freely available. There's no secret to this stuff. We tell you the standard. We let you test yourself before you get there, because we want to populate that registry with conformant units of conformance and really make this approach success. The tab is conformance guidance, and that tab does step you through the phase, the verification process, the certification process, and finally the registration process. Our communication guide that I mentioned previously has recently been published, and our goal is to get that linked directly through the steps in this conformance guidance. We're not yet, but the committee that I'm a member of is working hard to continually improve this landing page and this tab to the software supplier and integrator or whomever understand and get through the FACE conformance program and processes. The tab there with the green check mark on it is a link to conformance authorities. I mentioned them before. We have verification authorities, and we have one certification authority. Those there, as you drill down, will provide contact information to our current verification authorities and also directly to our certification authority. Excuse me. Lastly, we have a tab for frequently asked questions, just ones that have continually bubbled up either at face-to-face meetings or through events such as this webinar. And also there is a conformance definition listing there. So if you have a question, face terminology, hopefully it'll be answered there. Okay. So now I'm going to step through the prepper and then the other three official steps of conformance in a little more detail, and it may spur some questions, which we'll do our best to answer once I get through these slides. So the role of software supplier there on the left, of course, very important to your references and your tools. The repository, also known as the Open Group Store, can be via the FACE landing page, via the Conformance tab. You can Google it. There's a bunch of ways to get to this stuff, and we are absolutely not trying to hide it. We are trying to get it available. If we had a mailing list, I would think people send it out. But by all means, get these documents. Read through them. I'm not a software developer, but I'm told that this is not building rockets. While it may fly on aircraft, it is straightforward, and the standards and the technical requirements in the technical standard are not new. They are certainly being driven, as Opus said, through interfaces and then some control of the development inside the segments, but we're not inventing things here to make this difficult. We are trying to ensure portability and reuse. So, references, the next thing that is recommended to do in preparation is to reach out to one of the verification authorities and establish a relationship. And there's really two relationships that are there. One, a legal relationship. There's a verification agreement between the software supplier and that VA that sets out what will be performed by the VA, how many times would it be performed before it would be renegotiated if there's difficulties. Also, what type of evidence needs to be provided and what methods would be used to exchange that information and provide feedback. Done on an individual basis by each VA. The consortium doesn't get in that business. Our issues, we certainly want to be aware of them, and we will do our best to address them, but the VAs are independent authorities. How approval of the consortium, they can't perform the verification role. The relationship between the software supplier and the VA is really the working back and forth to ensure that the successful verification of the submitted software or that unit of conformance that was addressed earlier. And conformance is the element that FACE conformance is based upon, and it can range from an operating system to a portable segment component. Some may be very small. An example I'd offer is just something that keeps time. To an OS, which you can imagine is a much larger block of software. So one of the questions that comes up frequently is, well, how much is verification going to cost? And the answer that I give, and it may not be popular, is, well, it depends. And it depends on how big the unit of conformance is, how many there are, how well prepared the evidence is when the software supplier provides to the VA. So this is where that relationship and that communication is critical. So that goes on, then the software supplier on the third oval, that square on the left, on the left would develop their unit of conformance. There's a lot of references on how to do that. Certainly the technical standard is a key one, the reference implementation guide, and there's more help on the way. So certainly a doable process. So that is to establish a library portal profile, and we'll talk a little bit more about the library portal here in just a second. Okay, here's the second address URL that I would recommend note, and mine is, of course, webinar will be available, but I think these slides will also be available. And so the library portal has two major parts to it. One is it has the FACE registry. And the registry is the public, under the public listing of conformant units that are available through the representatives that are listed there. It does house software. You don't download your app from this registry. What you do is you obtain the description of the application or the UOC and point of contact and how to get to them to negotiate obtaining one of these units of conformance. Again, they won't on the registry if they haven't passed muster all the way through verification and certification. And the other piece, which is the UOC management. And this can be used by software suppliers starting from verification all the way through registration. And we'll talk about what steps are required and which ones are optional. Okay, I'm going to do a series of ODAF diagrams, and these particular ones are called OV5Bs. All sounds, at least to me, it's a little intimidating to talk about ODAF diagrams and their particulars, and these diagrams can in fact look a little busy, but please don't let them scare you. Again, this is not rocket science. We just wanted to be able to provide a logical step through. If you think back to the perfect or more perfect diagram, this is really the major pieces of the FACE Conformance program. But we look at this, we can see that, you know, the software supplier who during established that relationship with the verification authority submits their software verification package, which contains some paperwork, contains some compiled object code for the test environment, and some instructions on how that was made and how it would run with the test suite, so the verification authority can do that. There's certainly room for back and forth. The verification authority performs the assessment through addition of the design documents and information provided, and then conducts the for the record test using the approved test suite. Again, the software supplier has full access to that exact same test suite, so that, you know, there should be no surprises. They perform evaluation. If there are some issues, then there's some back and forth. Feedback is provided. All this done all in accordance with the FACE consortium policies and processes, but also in accordance with that verification agreement that the supplier and the VA have entered into. Once the UOC passes, the VA would create the verification results package, provide back to the software supplier, and then VA also archives that data in a element library called the Verification Retention Repository. It's there just in case of audit or other need to change that particular software and was assessed, or in case the VA should come up under audit. So verification. Then again is certification, and again the software supplier controls the timing and of all these steps. If contractually you have a timeline to meet, you'll have to back plan that. But especially if it's perhaps an IRAD development, or if a software supplier wanted to hold announcement of a particular unit of conformance for marketing reasons, or maybe at an unveiling of a product or something, that could be done, and it's again under the software supplier's control. So the supplier reaches out to the certification authority. In this case, let me back up just a second on a thought on verification. While it's not mandatory, that library portal account that we mentioned a few slides ago can be used to help step through verification, to exchange information, to obtain references, and that sort of thing. How it is not mandatory. But once you move into the certification, then the library portal tool must be used. That's the method of submitting information to the certification authority by the software supplier. The certification authority, again, only one, it goes into that library portal, looks at the documents provided, reaches back to the verification authority to ensure that unit of conformance did in fact pass verification. Assuming that all things are in order, they create a conformance certificate, and that's issued to the software supplier, and of information was submitted along with that certificate is put in a certification retention repository for keeping. What I didn't mention here is that there is an agreement between the software supplier and the certification authority that part of being certified is that the software supplier warrants that their unit of conformance not only meets conformance to the FACE technical standard, but will continue to meet it. So if an issue is found, the software supplier either needs to repair and correct that issue, or their certificate will be pulled. And that's in that certification agreement, and exposed early on, so there's it's no gotcha to that. As you proceed through this, it's explained very clearly in our guide and in several other documents. The last step is conformance registration, and this is done through that library portal, through the library administrator who runs the registry. The software supplier through applies for registration, can list product description of their UOC, so it's a free text field along with some established metadata that help describe the product, that UOC, for anyone who's looking at the registry. The administrator, once they receive the request, will reach back to the certification authority to ensure that the UOC that they're desiring to have listed did receive a conformance certificate. They verify that. The administrator receives that verification and reviews the posting, and then pushes it up onto the FACE registry. FACE registry, again, this is another one I would stress is very important. This is the public acting of your conformant UOC, and this is where project managers and system developers are going to go look for these existing UOCs and understand that they have the pedigree of having been through this conformance program and received certification. So important to follow it through all the way till the end. So did we get everything perfect? Absolutely. But what if there's an issue? Okay, the the FACE Consortium has a problem and change request ticketing system. Another website they're listing. Hopefully you won't need it, but if you do, it's there. It's a step-through tool where you can submit an issue, either a question, or if you think you found an error or something missing from, let's say, the conformance policy or one of the technical standards, it can be put in there. It will be triaged and addressed, and feedback will be provided. The answer may just be an explanation. It may be, hey, we've already dealt with this one, or if it's a valid issue, it will certainly be addressed in a efficient manner and a thorough manner. The problem reporting is actually specific to Conformance, and that is if there's an issue that's valid, that is preventing a software supplier getting their UOC through the Conformance program, that goes through an expedited process, and a item called an approved correction can be developed, allowing to be completed as and tools or what hated those approved corrections would be rolled into those tools and documents to make sure that any issue was found is corrected. That doesn't work if it all gets, or there's questions or there's disagreements that can't be solved in Conformance. There's an appeals process, and the submitter, possibly and most likely the software supplier, but it may be a verification authority might appeal something. And the FACE Consortium Steering Committee, and they will review the appeal and make a decision. Yes, the appeal is approved and changes will be made, or it's denied, no changes made, and is the final decision. There be a problem. We are not editing them and are not anticipating them, but we have a plan if they should occur. That's a level walkthrough, and I certainly wanted to leave some time for questions. But I wanted to walk through the process, provide links to roles, policies, and some procedures, and at the point, certainly call you all to action as software suppliers, especially to get your product certified, and get the registry populated, and let's continue to make the FACE initiative a success. And so I know that in my slides, and I think Judy is now when we move to the Q&A section. So
Yes, at least two questions. Can you hear me okay?
Judy.
Okay, very good. Okay, so the first question, as the FACE standard matures or changes, will updated conformance standards that require suppliers to develop new UOCs and re-verify through a VA, or is the goal to maintain back compatibility? Steve or Marcel, I'll defer to you guys to answer that question as you feel the need.
Hey, let me take the first part because I taking the easy part. So conformance of a UOC is to a specific edition of the technical standard. So that conformance certificate will list which standard, which version of the test suite was used to test it, and so it's tied to that. If a source supplier wants to be certified conformant to a follow-on standard or perhaps a preceding standard, they would have to go through a separate verification and certification for that particular edition of the tech standard, and utilize the test tool that's a link to that. And then I think that answers that question. And I don't want to spot Marcel, but I think you'd do a better job on the backwards compatible part.
So there's two pieces to this. So the architecture that I described is an abstraction and interface standard. So there's two ways to look at this. If I am taking a software components designed to edition 2.1 of the standard, I want to integrate it into a system that's using edition 3.0 of the standard. There is an adaptation opportunity to deal with that change utilizing the requirements of the new standard. We can mitigate that, so rather than taking that 2.1 component, I may not have to actually change it. I may be able to interface with it. However, if there are some other things or there's a business desire to migrate it, we would probably have to do some rework to do that. To mitigate how much rework, the technical working group maintains backwards compatibility matrices between going forward from 2.1 and going forward, so that if someone wants to go from 2.1 with their component to 3.0, they are aware of any potential impacts that may have happened. In this is, though, the guidance and goals and objectives of the technical working group is to make the ensuing standards more restrictive, but rather extend them. So while a 3.0 component may not go to 2.1, is that older versions would easily be integrated into new versions of the standard, or systems that incorporate components from newer editions of the standard. So it's kind of trying to hit it all sides, like Steve mentioned on the conformance side, but on the technical side, we're trying to minimize impact as much as possible.
Okay, thank you. And I have one more question. What kinds of cases apply with the verified UOC certifiable?
So this is Steve Getz, and I'll take that one because I take the easy ones. So it's possible. The certification step is very non-technical. The certification authority is reviewing basically 4 documents. The statement of conformance, and that's provided to the VA early on, and that is where the software supplier describes their unit of conformance and how they meet the requirements of the technical standard. So it has been through a technical review, and then it is provided to the CA. The statement of verification, and that's where the VA, on successful verification, fills out this PDF fillable document and states that basically the environment in which the UOC was assessed, against which technical standard, using which test tool, which condition requirements were involved, and there's there's certainly a short list of items that are annotated on that form. The certification agreement, and that's going to be there because that's does 2 things. One, I mentioned it provides the warrant by the software supplier that they have software and will maintain it as such, and so ensures that the certification authority gets paid for doing their job. So that won't be there. And I know I meant that 4, and I'm coming up with 3, and I can't come up with a 4th. But if you go to the guide, and it may only be 3, I apologize. I'm drawing a blank. So the certification authority is going to make sure that those forms are completely filled out, correctly filled out. An example I think that might be a little putty is perhaps a part number that's listed on the statement of verification versus what's listed on the software supplier's statement of conformance. Maybe a number gets transposed or something like that. That would be the type of thing I think that's possible could happen. But as far as technical are assessed durification. So I hope that answers your question.
Okay, I have one more question. I just need to find it. Give me a minute. So it'd be more typical to certify a single UOC at a time, or to certify a set of related UOCs that together provide a fully functional solution to requirements.
So we have a concept, I'm not quite sure what to call it, called a UE package, okay? And there's not particularly a technical reason for making a package of units of conformance, but there's likely a business decision in making that. Yeah, absolutely. If a group of UOCs complement each other and provide like you said, a mission capability, that's to do that unit of conformance package. Rises that package has to be individually verified and certified, and the certificate can be issued for the package. There is that would be listed individually, certainly, but also it could be listed as a package on the registry, so that if you as a provider wanted to, say, hey, I've got this greatest, capability that, whatever makes time travel possible, or the photon torpedo, that's something you want to get out there. There are additional requirements to a UOC package, and basically you top to the bottom on the architecture, because what we end up doing there is break-in portability. So during assessment of that package, it would be checked to make sure that it didn't violate the rules, and there's a diagram and depiction in the tech standard that clearly lays out which segments in combination can't be crossed. So I hope that question. And let me add one last thing. If you stack of UOCs that are not related that you want to push through all at once, there's no restriction on that either.
Okay, Steve, I'm looking at one more question. UOC is registered. Does it include source code, or is it just an executable?
So when a UOC is registered, it includes no code. It includes a description of UOC. There's some free text fields, and again, there's a long list of metadata stuff, and I'll be able to quote it to you, but what it resides in, what technical standard edition it was or certified to, things like that the buyer is going to want to know, and then it contain perhaps name, phone number. How do I get a hold of the software supplier who produced this great certified conformant UOC so I can purchase it or it? No code is stored in our in that particular part of the library. The product repositories, which are maintained by the source suppliers, is where that code would be housed.
Okay, thank you so much. I almost said brilliant because I'm on the other side of the pond, but I
would have taken brilliant.
Okay, I have one more question that came in from the participants. One, still the latest and greatest, and what is the status of Phase 3.0?
2.1 is the latest and greatest. 3.0 is on schedule to be published in summertime of 2017.
In response to the call to action, I do want to announce, as of earlier this morning, it's probably earlier this week, but on holiday most of the week, so I found out earlier this morning, that we do have our first certified face conformant UC listed in the face registry. It is Rockwell Collins Mission Flight Management Software Application. It is one of the portable components in the face software stack and the reference architecture. And I'm very proud to announce that we have officially complied to the face conformance program through verification, certification, and we have our first face conformance software product listed in the face registry. So on that happy note, if you have any more questions, either indicate them in the chat or indicate them in the Q&A. I do see something coming in the Q&A. One more question. Let me just check. Policy on who or how many accounts a supplier can have for the face library. And Steve, that's a better question for you. In the left.
I'm aware of one, and I imitation, and I'm trying to understand why there might be one, but no, not to my knowledge.
Okay, so I do know the person who asked the question personally. If you send me an email with that same question, either the subject line or in the text, I can do some investigation. And if you're having difficulty on that type of information, I can do some investigation and find out for you. My understanding is that accounts should be on based, so it could be either individual or it could be company based, and I'll get more information and I will get back to you. So if you would send me an email, I can do an investigation and let you know. In the 30 seconds that we have before we switch from 4 o'clock to 4:01, are there any final questions, parting words, closing thoughts from any attendees, anyone on the panel that you would like to embellish? Going twice. So I'd like to thank all of our attendees for participating today. Very pleased with the turnout. I'd like to thank Marcel Padilla from NavAir and Steve Getz from US Army AMRDEC. I'd like to thank Simon from the Open Group staff, Mike Hickey from the Open Group staff for participating and keeping us in check. And with that, if you have any additional information, feel free to send me an email, j.sorenzia@opengroup.org. You can inquire for more information on www.opengroup.org/face, and we'll hear from you and look forward to seeing more of our members and non-members submit for the certification process, conformance process, and see more certified conformance software populating our face registry. Thank you for joining today, and you have a good afternoon and a good evening.